Okay, so Friday we went over the 10 questions from Unit 1 and the 10 questions from Unit 2. However, after working out the actual midterm this morning, I feel like I need to go into some more detail on 2 of those questions. So let's look at page 1, number 7. Find the inverse of the following. Okay, normally this would be a very simple question. You would just type this in using Alpha Zoom, and then you would use that x to the negative 1 button, and it would raise it to the negative 1, and it would give you the inverse, right? What was the inverse it gave us Friday?
1, negative 5, 2, negative 1.
Okay. However, the problem is, on the actual midterm, it doesn't give you the final answer. It gives you the answer or the answer choices are like the word. So, you know how the inverse, you can do it by hand, by doing 1 over the determinant times the crazy matrix. Okay, and the crazy matrix is where they flip-flop the A and the D, so negative 1 would come up here, 11 would go down there, and then B and C just change their sign, so that negative 5 will become a positive 5, positive 2 would become a negative 2, and then you'd have to fill in the determinant. How do we find the determinant of this matrix? Guys, how do you find the determinant? Right, so A times D is negative 11, minus B times C is negative 10, but then that becomes plus, and so your determinant equals, that's what the answer is going to look like on the test. It's going to leave it like that. It doesn't take it all the way to the final inverse. Now, if you don't remember how to do this, and all you know how to do is type in this and raise it to the negative 1, here's my best suggestion. You're going to have 4 choices on the test that look like this. Couldn't you simply multiply this scalar by each element to see which one produces that? Like, look, isn't 1 over negative 1 just negative 1? Negative 1 times negative 1 is positive 1. Negative 1 times 5 is negative 5. Negative 1 times negative 2 is positive 2, and negative 1 times 11 is negative 11. So see how when you actually multiply out this by every element, it gives you what the calculator gave you? So if you don't remember how to do this on the test day, you just can look at A, B, C, and D and multiply out each choice until you get what you got when you did it by the calculator. No, it'll be whatever A times D minus B times C gives you. Okay, now the second problem as I was working through the actual midterm that I came to and felt like we needed to go more in depth with is on page 2, number 5. So flip to page 2, go down to number 5. Okay, so for this one it says find g of f of 3 if f of x equals x squared and g of x equals 2x minus 6. So we just plugged in the 3 into the f function. 3 squared is 9. Then we took that 9 and plugged it into the g function. 2 times 9 is 18, minus 6 is 12. However, when you're taking the actual midterm, it doesn't give you a number to plug in. It does something like this, f of g of x. So when it gives it to you like that, what do you do? Correct. You plug the entire g of x function into the f function. So instead of x squared, we plug in 2x minus 6 into the x and then square it. Right, 2x minus 6 squared is just 2x minus 6 times 2x minus 6, which then we would have to FOIL. When you FOIL it, you would get 4x squared minus 24x plus 36 is your final answer. I went ahead and did the outer and the inner in one step. Okay, so does everybody see what to do if they don't give you a number to plug in and they just give you x? You plug in the entire function into the other function. Okay, so now I feel like we've reviewed as well as we can for units 1 and 2. So now go to page 4 and we'll begin reviewing for unit 3. Yes. Alright, operations with polynomials and complex numbers. Expand x minus 4 cubed. What could you use to work this problem? Okay, doesn't x minus 4 cubed literally mean x minus 4 times x minus 4 times x minus 4? And so we could FOIL these first two, and then whatever we got from that, distribute it to this leftover binomial. But that's a lot of work. What's something else we can use besides that? Right, Pascal's triangle. Now, you're going to have to create that triangle on your own. So let's review how to create it. It's very simple. Okay, look. Ones go down the diagonal, the outside diagonal. Okay, so that's one thing you have to remember is that ones go down the diagonals. Now, after that, it's easy. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So what would the next row say? 1, 5. Right. So I'm pretty confident you can create that triangle yourself. Now, once you've created the triangle, you can use it. Since we're dealing with a binomial that's cubed, which row of the triangle do we look at? Correct. The first one that has a 3 in it. Okay, so 1, 3, 3, 1. Okay, after that, what goes on each of those numbers? The x, because that's the first term. Okay, and then after that, the negative 4 goes on all of them. And since it's a number, we put it in parentheses. Because if you don't put that negative 4 in parentheses and you just write it out to the side, that's going to look like 1x minus 4, 3x minus 4. So that's why you put it in parentheses so that it's 1x times negative 4. Okay, now, x is raised to the what power? The third. The first term starts out to the third power, and then from there it decreases. And so the negative 4 would do the opposite. It starts out to the 0 power, and it increases. Okay, y'all remembering that now? Okay, from here, we're just going to simplify. Like this first term, isn't that basically 1 times x cubed times, what is negative 4 to the 0 power? What's anything to the 0 power? Type in something to the 0 power. 1. Think about it, guys. If you're telling me that negative 4 to the 0 power was 0, wouldn't that cancel out the whole first term? Because 0 times anything is 0. And have we ever had one of these cancel out everything? No. So anything to the 0 power is 1. What's 1 times x cubed times 1? X cubed. So we're done with the first term. Okay, second term. We have a 3 times an x squared times a negative 4. Negative 12x squared. Okay, and then the next one, we have a 3 times an x times a positive 16x. Because remember, it's squared, so a negative times a negative is a positive. Now, what's 3 times 16? 48, and then don't forget about the x. Okay, then the last one, we have a 1 times a negative 64. Because remember, it's negative 4 times negative 4 times negative 4. So 1 times negative 64 is negative 64. Okay, now let's also talk about some things that could help you eliminate wrong answers. Since it was cubed, didn't we look to this row? And that row has 4 terms. Okay, your answer will always have a term higher than the exponent was. So like this one down here, number 2, how many terms is its answer going to have? 5. So that could help you mark out some of the wrong answers by just looking at the amount of terms it has. Also, you can look at the signs. Anytime it's a subtraction, the signs alternate from positive, negative, positive, negative. If it's positive in there, they'll all be positive. There will never be a case that it's all negative. Okay? So does everybody understand how you could eliminate some wrong answers by knowing how many terms you should have and what the sign should look like? Okay, now let's try number 2. X plus 3y to the 4th power. Since this was to the 4th power, how many terms are we going to have? 5. So we look to this row that has 5 numbers. 1, 4, 6, 4, 1. Okay, then on each of those numbers, the first term we put is x. Okay, and since x is the first term, it gets to start out to the 4th power, and then it decreases all the way to 0. Okay, then our second term is that 3y. So it gets placed on all of them. Okay, and it does the opposite. See how this one was to the 4th power? That means this one has to be the 0 power so that they'll add up to 4. So if this one's to the 3rd power, this one has to be the 1st, so they'll add up to 4. So this one would be squared, and then to the 3rd, and to the 4th. Okay, now from here, you just start to simplify. We have a 1 times an x to the 4th times a 1. Anything to the 0 power is 1. So that produces a x to the 4th. Then in the second term, we have a 4 times an x cubed times a 3y. Because 3y to the 1st power is just 3y. Well, now we can multiply the coefficients. 4 times 3 is positive 12. X cubed times y is x cubed y. Okay, so in this next one, tell me what we have. We have a 6 times a 9y squared then. Because look, you square the 3, which makes the 9, but then you still have y squared also. So now 6 times 9 is 54. X squared times y squared is just x squared y squared. Okay, so in this 4th term, we have a 4 times an x times a, what's 3 cubed? 27. What's y cubed? Y cubed. Then you do 4 times 27 and you get positive 108 and then xy cubed. Okay, then the last one, we have a 1 times, okay, what is 3y to the 4th? 81y to the 4th. Okay, so you have to do 3 to the 4th, which makes it 81, and then y to the 4th, which is y to the 4th. So that becomes positive 81y to the 4th. And see how we ended up with 5 terms? You always end up with a 1 term more than the exponent is. Okay, number 3. 8x cubed plus 24x squared plus 24x plus 8 is the expanded form of which of the following? Okay, well how many terms are there?
4.
So what should the exponent be? A 3. So that rules out A. Okay, now, for B and C, they both start out with a 2 to the x. And that makes sense because 2x cubed is 8x cubed. But then we have a 1 cubed and a 2 cubed. To produce this 8, what would you have to have? 2 cubed. So it's C. Okay, number 4. Simplify 6i over negative 8 minus 6i. You know how last year or the year before, I can't remember, and we also talked about it this year, the fact that you can't leave a radical sign, a square root sign in the denominator? Well, you also cannot leave a I in the denominator. Does anybody remember how we get it out?
Multiply.
We do multiply, but by what? The conjugate. So y'all are all on the right track. You multiply by the conjugate of this, which is what? Right? When you're doing the conjugate, the only thing that changes is the complex number. See how negative 8 stayed negative 8? You only change the complex number sign. So it changed to a plus 6i. Now we have to do that top and bottom. Let's talk about why you have to do a top and bottom. What does anything divided by itself equal? 1. 1. Is multiplying by 1 really changing the problem? No. So it's just a method to get the I out of the bottom, but it doesn't change anything because multiplying by 1 doesn't change anything. So now when we look at the top, we see that we have to distribute. 6i times negative 8 is negative 48i. 6i times 6i is, right? Okay, what does I squared equal? A negative 1, and so that turns this 36 into a negative 36 because they're touching, so it's multiplying. So it turns it into a negative 36 and then minus 48i. Now some of you may be wondering, why did you reverse the order? Remember with complex numbers, they always have to be written a plus bi. The real number first, the complex number second. But we're not done because we haven't dealt with the denominator. How do we simplify the denominator? FOIL. But not everybody will remember that, so we'll do it anyway. Okay, negative 8 times negative 8 is positive 64. Negative 8 times 6i is negative 48i. Negative 6i times negative 8 is positive 48i. And negative 6i times 6i is negative 36i squared. Now, some of you may remember, I know Eric did, the outer and the inner always cancel each other out for these, and doesn't that make sense because we wanted to get rid of the i's, and we just did? Negative 48i plus 48i cancels. What is negative 36i squared? Positive 36, so when you add that to 64, you get 100. Okay, and that answer is correct. However, that's not the choice you'll see on the test. Why not? Correct. We can simplify it by reducing it. So let's review where the N over D button is. Where's the N over D button? Alpha y equals, there's N over D, number 1. And then, hold on, I've done this. Let me try that again. Alpha y equals N over D. And then first I'll start by reducing the negative 36 over 100. So negative 36 over 100 equals negative 9 over 25. Then I have to go back and reduce negative 48 over 100. So alpha y equals negative 48 over 100. Right? And then don't forget that that's the part with the I. So that's the final answer. And remember how when we're doing complex numbers, we always split it like that? So you have a real part and a complex part. All right, number 5. What is the conjugate of 8 plus 4i? 8 minus 4i. Some of y'all need to wake up. Number 6. What are they wanting us to do with that problem? FOIL. So 4 times 5 is 20. 4 times 3i is positive 12i. Negative 2i times 5 is negative 10i. Negative 2i times 3i is negative 6i squared. Okay, then what could I do? Okay, which ones are the like terms? And that makes 2i. Okay, so they're gone because we combined them. What else can we do? Correct. Negative 6i squared is just plus 6 because that I squared turns a negative into a positive. And so now we have 20 plus 6, which is 26, and it has to go up front because A plus BI. Your real number's in the front, and then your complex is last. All right, number 7, what do they want us to do? Okay, by. Isn't that just multiplication? What's negative 6i times 9i? And I squared equals negative 1. And so a negative 1 times a negative 54 makes that a positive 54. All right, number 8, I cubed. I cubed, isn't that just I times I times I? Okay, well, don't the first two i's make an I squared, which we all know equals a negative 1, and then you've got that I left over. So negative 1i, which they would just write as negative I, because you don't have to write the 1. Okay, y'all ready to move to number 9? Alright, number 9. What is the product of 3x minus 5 and x plus 8? What does product mean? Multiply. So when you have a binomial and another binomial and they want you to multiply them, what are you doing? FOIL. 3x times x is 3x squared. 3x times 8 is 24x. Negative 5 times x is negative 5x. Negative 5 times 8 is negative 40. And then what do we do? Combine like terms. So which ones are the like terms? And that makes a positive 19x, and then just bring everything else down. 3x squared plus 19x minus 40. Alright, number 10. If f of x equals 2x to the 4th minus 4x squared, what is f of I equivalent to? Okay, so see over here how they say f of x, but all of a sudden it's f of I? Doesn't that mean they've replaced the x with an I? So shouldn't we go through the equation and replace all those x's with i's? Okay, anything you see right away you can do? Right? Right. This I squared, which is a negative 1, makes that negative 4a positive 4. Okay, now 2I to the 4th. Let's break down I to the 4th. Isn't it I times I times I times I? So that's 2I squareds, right? And what does each of those I squareds equal? And what's a negative 1 times a negative 1? So doesn't I to the 4th really just equal a positive 1? So you get a 6 for your final answer. Alright, unit 4, graphing polynomials. Where are the zeros located on the graph? Okay, well how many zeros are there? 3. So that rules out B and D. And are they at negative 1, 2, and negative 3, or positive 1, positive 2, positive 3? They're all positive.
Wait.
But you don't have to write it out twice. Like, cause, yeah, I mean, it is a bounce, so technically that's a multiplicity of 2 right there. But you don't have to write 1, 0 2 times. Alright, number 2. For this one, instead of labeling them true or false, let's just circle the right answer. Okay, A says that it has an even degree and is positive. Is that true? Or, never mind, is that correct? No. It's definitely not even, and it's definitely not positive. Okay, what does it take to be even? Same direction. Okay, so B is out, because it also says even. C says it's odd and positive. Is that correct? It is odd, because they go opposite ways, but is it positive? No, it's going down on the right. So that means D is correct, because it is odd and negative. Alright, number 3. Describe the end behavior of the following graph. Okay, for end behavior, they'll always give you this part. They'll always say x approaches infinity and x approaches negative infinity. Now, which way does the x-axis run? Which directions? Left and right. So if it says x approaches positive infinity, which direction is that? Right. If it says x approaches negative infinity, that means go to the left. So they'll always give you this. You just have to know that this one means right and this one means left. They want you to tell what the y value approaches as it goes right and as it goes left. So if we're on this and we travel to the right side of it, we end up going down. If we're on it and we travel to the left side of it, we end up going up. Doesn't it make sense that we got 2 different answers because they're opposite, they're odd? Okay, so now that we've done that one, why don't you take a second and try number 4 first. You'll have to graph it and then tell the end behavior of that graph. As you went to the right side of it, it was going up. So that would be written as x approaches infinity, that means right. Y approaches infinity, that means up. Then as you went to the left side of it, what did it approach? down. So you're looking for as x approaches positive, y approaches positive, and as x approaches negative, so does y, and that was A. Okay, number 5. Find the zeros of the function. Well, currently it's in factored form. So when we write out the zeros, what will happen? The signs will change. So what are our zeros? Okay, and if you're not sure, you could always graph it, and you'll see that it crosses at -7, -5, and 2. Okay, number 6. Sketch a graph that would have no real solutions. What does that mean? It doesn't touch the x at all. It doesn't touch it or cross it. So like a parabola that got shifted up the y-axis, is that ever going to touch or even cross through the x-axis? No. So that would be a graph with no real solutions because it never touches the x-axis. Alright, next page. Tell the degree and the leading coefficient of the following graph. Okay, what's the degree? 3. Now, it's a little tricky because you're thinking, well, it only goes through right there at the origin, but what is it doing right there at the origin? Flattens out, which is a multiplicity of 3. Plus, if you said 1 because it goes through once, what's the degree 1 graph look like? A straight line. Degree 2 is a parabola. Degree 3 looks like this. I just call it a snake. Okay, is this positive or negative leading coefficient? Negative, because it's going down on the right. Alright, number 8. Graph the following function in your calculator and state the interval of increase. Okay, so let's graph it. Y equals x minus 2 squared times x plus 1. Okay, how many times is that graph increasing? Twice. It's increasing right here, and then it decreases for a short amount of time, and then it increases again. So you know your answer is going to have two things. Now, when did it start increasing? Right, and since it's going down, negative infinity, right? Or not really down, left. Because we only look at the x-axis, so it's going left forever as it goes down. When did it quit increasing? It is 4 on the y-axis, but remember, we only deal with x values, so that'd be 0. When did it start increasing again? 2, and then it increased forever. So 2 to infinity. Alright, number 9. Write an equation that could represent the following graph. Okay, well, instead of writing the equation, let's write down all the characteristics we notice about it. It's negative. How do you know that? Well, it's going down on the right, so that makes it negative. It's odd because they go opposite directions. What's the degree? 5. Okay, let's talk about 1. Here's an x-intercept. Here's 1 and here's 1. That's 3. This bounce counts as 2 more, so it's degree 5. And you know your degree has to be an odd number because we already said it's odd because they're going opposite ways. You could also tell where the zeros are. Like this one's at negative, is that negative 1, 2, 3, 4, 5, 6? So like this would be x plus 6. This would be x plus 1, but squared because it's a bounce. This would be x minus 3 and x minus 5. And so if you write all those factors out, that would be the equation. You have to put a negative out in the front. So let's just do that real quick. They call this g of x, so g of x equals negative. I'll do the bounce first. X plus 1 squared times x plus 6 times x minus 3 times x minus 5. And look, 2, 3, 4, 5. Degree 5. I forgot the equals to. Alright, number 10. Does the following equation have a maximum or a minimum? Okay, well, to know that, we need to graph it. So y equals x to the fourth minus 2x cubed. Crazy. I don't know, it's spazzing out. Okay, minus 3x squared plus 4x, and is it plus 4 at the end? Okay, we graph it. They want to know if it has a max or a min. A min. It doesn't have a max because doesn't it go up forever on both sides? So we could never put our finger on the highest point because it keeps getting higher and higher. But we could put our finger on the lowest point and actually two lowest points. It has a minimum at -1, 0 and 2, 0. And that's called an absolute minimum because that's absolutely the lowest the graph will ever go. Now it has a relative maximum right here, but not an absolute maximum. Okay, now quickly, before you stop paying attention, I want you to listen for a second.